Then we have to talk about so whenever we are talking about river crossing problem, then we'll talk about resultant. And there are two scenarios. One is the shortest time. So the man travels in this direction and its resultant becomes this. So this would be the shortest time. But we have also the shortest distance. So the man wants to cross this river due to the flow of the river. His resultant would become this. So this is the shortest distance, right? And then we have talked about this circular motion, uniform circular motion, and what are the right. So what is angular motion? What is angular displacement? Angular velocity? Angular acceleration? All these things we have talked about, and yeah, there's a relation between angular velocity and the linear velocity. So these things we talked about in the last class, right? We did some questions on projectile. This we have done. Now we were doing some questions on, right. So we were doing some questions on the river crossing problem and the problem, right? The particles P, Q, R are moving along the vectors. Respectively, they strike on a point and start moving in a different direction. Now particles. Okay, this is a cross product relation. So this with right. So now we will do this question. The speed of a swimmer in still water is 20 meters per second. So this is velocity of the man is so velocity of the man is given, and this is 20 meters per second, right? The speed of river is 10 meters per second. So speed of river is given 10 meters per second, and it's flowing due east. So we have this direction, right? North, south, and what is this? East and west, right? So river is flowing in this direction. This is the flow of the river, and let's say this is the width of the river. If he is standing on the south bank, so the man is here in the south bank, and then he wished to cross the river along the shortest path, right? So this is the path, this is the resultant, right? This is VMR. So the man has to travel with this angle. So this is the velocity of the man, and this is the velocity of the river. Right, we have to find out the angle, at what angle he should make the stroke with respect to north. So with respect to north, right? This is the north. So with respect to north, what is the angle that we have to make? This is the theta that we have to find, right? So then what is the angle, right? So we know that what is VR and what is VM. These things we already do. So tan theta would be how much? This would be simply VR by VM, right? So then what is this? What would be this theta? VR is 10, and then this is 20, right? Okay. The speed of the ants going to east if we standing on the south and wishes to cross the river along the shortest. Oh, so this we have to first find out, right? Because tan theta would be perpendicular by base. This is the hypotenuse, right? Not the base. So tan theta is VR divided by VMR. So VMR we have to first find out, right? What is VMR? So this is right. We know that VM would be root of VR square plus VMR square. So VMR, this would be simply hypotenuse square minus this perpendicular, right? So this is how much? This is 200, right, so this is 20 square minus 10 square. So 400 minus 100, and then this is root 300. So this is 10 root 3, right? This is 10 root 3. So we can now calculate the angle. So is 10, VMR is 10 root. So this thing will cancel, and tan theta we will find out this will be 1 by root 3, right? So what would be this theta? At what angle your tan theta is 1 by? What would be this theta? Yes. What would be this theta, guys? Yes. What would be this theta? Alia and Nabi, what would be this theta? So tan theta is 1 by root 3. At what angle tan theta is 1 by root 3? What is the angle? What is the theta for which tan theta is 1 by root 3? So theta is 30 degree, right? For theta equals to 30, tan 30 is 1 by root 3. This value you know, right? Tan 30 is 1 by root 3, so theta is 30. So theta is 30 degree, and we are going 30 degree west. So this would be the answer. Is it clear, guys? Is it clear?
Yes, sir.
Yeah. So whenever we are going in the shortest path, so we have to start with some angle, right? And then we can find this angle using this tan theta. So this was the question. Please note it down, and whenever you guys have noted, please tell me. If you guys have any doubt, please so if you guys have any doubt, please tell me. This was the best direction, right? So 30 degree. Yeah, please note this thing down, and then we'll do the next question. Yes. Whenever you guys have noted, please tell me. Noted, guys. Noted.
Yes, sir.
Yes. Okay. So now let us. right? And if you guys have any doubt, please don't hesitate to ask me, right? I will help participate. So yeah, if you have any doubt, please let me. Okay, so now I will ask the idea of this question, right? Let's draw the diagram. So a butterfly is flying with velocity 4 meters per second in northeast direction, right? So this is north, south, east, and west. So the butterfly, right? Butterfly is flying in the northeast direction, and the magnitude is 4 meters per second, right? This angle is because this is equal northeast, so this is 45 degrees, right? So can you guys tell me that? Oh, so what you are here? So this is the velocity, right? And the wind is blowing. So northeast direction wind is blowing from north to south. So this is the wind, which is right. This is velocity of the wind. This is velocity of the butterfly, right? But we want to calculate the displacement. So how do we calculate the displacement, right? So first we have to find out what is the resultant velocity, and from that we can find out what is the and from that we can find out what is the displacement, right? So what we should do? How can we find the resultant of these two things? How can we find that? Yes. So what is the idea that we have to use in this question? Yes, earlier, any clue? So remember this is a constant velocity, right? These are constant velocity, so we have to find only the distance, right? Okay, so let me just give you a hint. So we can write this VB, we can write the velocity whenever we have confusion. So the simplest idea that we have to write in IJ, right? This would help us a lot. So the velocity of the butterfly, this is 4 root 2 magnitude, angle is 45 degrees. So this would be 4 root 2 sine 40 uh, cos of 45, cos 45 I had 2, cos 45 is 1 by root 2. I had 4 root 2 sine 45 is 1 by root 2 j. Root 2 cancels and we have 4i plus 4j. This is the velocity of the butterfly, right? Now, what is the velocity of the wind? That is simple. Can you tell me what is the velocity of the wind? Yes. What is the velocity in IJK form? This is 1 meter per second. So what is the velocity of the wind? Yeah, please take a guess, right? Please, and just take a guess, right? Just think about it and tell me what is velocity of the wind. So we are moving in y direction, right? And this is negative of y. So this would be minus 1 j hat, which is minus j hat, right? Clear? Okay, yes, Iram, yes, hello, Iram, Assalamu alaikum. You have just joined. So we are doing the motion in Pvt chapter, right? And we're talking about the resultant and relative velocities. Motion in two dimensions, we're talking. Okay, so velocity is minus g hat, right? Velocity of butterfly is this. Vp plus Vw. This is how much? 4i plus 4j minus of j. 4i plus are you saying something? Found out the resultant velocity. So it has x component, it has y component. So velocity in x direction is 4 meter per second. Velocity in y direction is 3 meter. So we can find x direction. The velocity, right, which is into t. So this is 4 instance in y direction. This Vy into t. So this is how much? Vy is 3 into 3. That is 9. So now we have x component of displacement, y component. So we can write the vector as xi plus yj. X is how much? 12i plus 9j. So what is the magnitude? That would be the displacement, right? Root of 12 square plus root of 9 square. So how much is this? So this is 144 plus 81. So how much is this thing? Uh, 3 threes are 9, 4 threes are 12, so 5 threes are 15. So this should be 15, right? 5, 2, so this is 15 meters. So this would be the displacement. Is it clear? So we have to just write in the component form. We have used the idea of resolution of vectors that we have extensively talked about in the previous chapters. And we just use that and then this becomes very simple. So resultant of ijk, that is very simple. So that is the idea. We find out the velocity. It has two components, x and y. So x component will contribute to x direction distance. Y component will contribute to y direction distance. And then we just find out the positions in x and y, and then we just take the magnitude. So then we'll get the displacement, right? Is it clear, guys? Yeah. If it is clear, then please note it down, and then we'll do the next question. Yes, please note this thing down, and whenever you guys have noted, please tell. Whenever you guys have noted, please. Yes, noted, everyone. Noted, guys.
Yes, sir.
Okay, so then let us do the next question, right? So the next question is the easier one. Again, the same idea. We want to cross the river exactly opposite, at the point exactly opposite to the initial point. We are following this shortest path. And then for the shortest path, we want to find out what is the, what do we want to find out? Okay, so this question. A person swims in a river, right? So always it is better to make the diagram. This is the river which is flowing, and a person, let's say at this point, exactly at this point, he wants to cover or he wants to reach exactly the opposite point. So he will start from here, right? This is the direction that he will start. And this would be, so this is the velocity of the man. This is how the river is flowing, velocity of the river. And this would be the reservoir, right? This thing we have understood. So let me write it. Whatever notation we can write, so that is totally up to us. And this angle 120 degrees. So this is with the direction of flow of the water. So this is the flow of water. This whole angle, right? This whole angle is 120 degrees. So how much would be this angle only? How much would be this angle? From here to here, this is 90, so this would be 30. Right? We have this angle 30 degree. And what do we have? Its speed of swimming is zero point 0.5 at an angle of the direction of flow of water. So his speed of swimming, this is the resultant that is given, right? The speed of water in stream is. So in a river aiming to his speed of swimming is zero point 0.5 meters per second at 120 degree with O. So I guess this is the velocity, right, of the man. So this is 0 0.5. So this thing is zero point 0.5 meter per second. Velocity of man is given 0 0.5 meter per second. Velocity of the speed of water in streams, right? So we have to find out the velocity of the river or stream. That we need to find out. This angle is given. So how do we find this thing? Right. How do we find this thing? This is velocity of man with respect to. So this is given. Again, we will use. We want to relate, right? We want to relate this angle with this perpendicular and this hypotenuse. So what is the trigonometric ratio that relates these two things? What is the trigonometric ratio? For this angle, this is the perpendicular, right? This is hypotenuse. So we want to find out VR, velocity of this thing. Pm is given. So what would be the angle that we have to, what is the trigonometric ratio that we have to use? Right? Perpendicular and hypotenuse. What relates perpendicular and hypotenuse? Yes, this is the 10th standard question, right? What is the trigonometric ratio that relates perpendicular and hypotenuse? Guys can write it in the chat box as well, right? So if you're not responding, then I would assume that you are not understanding, right? So just please respond. Whatever the answer, don't think about the answer. Whatever the answer which is coming into your mind, just tell the answer, right? Tan theta. Oh, tan theta is perpendicular by base, right? Sin theta is perpendicular by hypotenuse. Yeah, so good that you have answered this. So whatever the answer is, don't bother about the answer, whatever the answer is. So we have to relate this perpendicular and hypotenuse. So we will use sin theta, right? So sin theta, which is sin 30, this would be perpendicular VR by hypotenuse, which is 0 0.5. So sin 30 is how much? That is 1 by 2. And then VR by 0.5. So VR would be how much? 0.5 divided by 2. So how much is this thing? So this is 0.25 meter per second. This was a simple question, right? Is it clear, guys? So only thing that we have to remember is that for the short, that is the only thing that we have to understand. Okay, yes, Nabil has joined back, I guess. So yes, please, if you guys have any doubt, please tell me, and otherwise, please note it down. Please note this thing down. Here. Okay, good. Yeah, please note this thing down. Yeah. So whenever you guys have noted, please
Noted.
note it. So now let us do the next question. The next question is same as this one, but only there is a small twist in this question, right? Okay, so where is yeah, I will talk about this question later, but let's do this question. Uh, how much marks we get from physics, chemistry, and bio, right? So you guys have your NRI quotas, right? So 15% of seat is 15% seat is reserved for you. So if you guys can score at least 30%, at least 30% in all of right, in all of these physics, chemistry, and biology paper, right? So then you guys can yeah, then you guys can get a good institution, right, or college. For you guys, yeah, I guess for you guys, so the question is of around 700 marks, right? So not 30%, but more than because the cutoff is, I guess, 600 or 550 something. But for you guys, that would be 400 to 500. So if you score in this range, then I guess you guys can get a good, right? So then you guys can get a good college. Yes, agree. So you have to score between these, right? Yeah, you want to qualify only. So for qualification only 400. How much is the qualification marks? Okay, so that I'll have to check, right? For you guys, because you guys have your quota. So for that, let me check and then I will check, right? So if I remember correctly, the qualifying marks was, I guess, 350 to 400, right? So 350 to 400, that was 150. 150, then the rank would be, so 150 would be for, I guess, the NRI quota, I guess. That should be, 150 is quite less, right? 150 is, or not. I'll have to check. No. I will check and then I will tell you, right? So first I'll have to check and then maybe in the next class I will tell you, right? So what was in the previous result? What was the qualifying marks for you guys, right? You don't have to think about the general quota. So general quota that has a huge right cutoff, but for you guys the cutoff is not that much, right? So you won't have to solve all those questions. You have to solve only selected questions, right? So you guys just have to prepare for that. Okay, I will tell you tomorrow. Okay, not tomorrow, but whenever we meet in the next time. So I will tell you the cutoff marks and what is how much you have to score in physics only, and then all those things, right? So and yeah, and go abroad. Good, yeah. So inshallah. Yes, inshallah. Surely, you will score that much, or maybe even higher, right? So, so
Sir,
yes.
sir, the cutoff is actually 160, 150 only. Not the cutoff, the qualification marks.
Oh, the qualification marks. But I guess you won't get the good institution, right? Good colleges. So maybe you'll
Yeah,
get private colleges, but for good institution or good colleges, you should score above 300 or
above 300, yes.
yeah, yeah. Yeah, because if you will not get the government colleges, right? And then the fees would be quite high for 150 or 160 or points per marks, right? Yes, so yes, Iram has told us, right, informed us. So if Iram is saying that, yes, Nabil, the qualification is 160. Right, and I will double check and then check you next. Right. Okay, so let's try this question. Yes, thank you, Iram. And yeah, so let's do this question. Again, we have this river, the speed of boat in still water. So again, I would write a man or let's say speed of the boat is 5 kilometer per hour and in still water it crosses a river of width 1 kilometer. So this width is 1 kilometer along the shortest possible path in 15 minutes. Right. So this time is 15 minutes. Right. If he is the velocity of the river water, right, in kilometer per hour. So along the shortest possible path, then the boat has to move in this direction, right? Then the boat has to move in this direction. This is the velocity of the river, and this is the velocity of the boat in still water. This velocity would be the resultant velocity, right? And what they have given, so this thing is given, which is 5 kilometer per hour. Time is 15 minutes, which is 1 by 4 hours, right? So time is given, distance is given, then what we can calculate? We can calculate this speed. What is this speed? So this is speed which is VBR. This would be distance by time. Distance is 1 kilometer, time is 1 by 4. So this is 4 kilometer per hour. So now we have got this thing also, right? VBR. And this thing we also know. Oh, we want to calculate VR. VB we know. Using the Pythagoras theorem, right? VB is VR square. Let me write it square and then VBR square. So if we want to calculate VBR, so this would be VB square minus VBR square. So how much is this thing? This is 5 square, this is 4 square. So we know that 5 square 543 is the right. If this is 5, this is 4, so this would be 3. So VR would be 3 kilometer per hour. Right. So this would be the option. Is it clear, guys? If it is clear, then quickly note this thing down and then next question. Okay, good. So please note this thing down, guys. Yeah, these are very simple questions, right? And 38th question is the same, right? So with this, and then we'll talk about the name. Yes, noted, guys.
Yes, sir.
Okay, so then uh, and okay, so this question: a boat is sent across a river with velocity 8 kilometer per hour. Is the resultant velocity of the boat? So this is a direct problem, right? This is the direct problem. The resultant is given VBR. This is 10 kilometer per hour. And oh, this one is bigger. How is this possible? So if okay, so which means that we are not going in the shortest path, right? So yeah, this thing you have to be careful. Which means that this is 8 kilometer per hour, right? This is the velocity of the boat, and then this is the resultant VBR. So we are not covering the shortest path, right? We are not covering the shortest path. This is 10 kilometer per hour. And we want to find out this velocity, VR, which is what? So this is simple, right? VR would be simply VBR square minus, this is 10 square minus 8 square over, so 100 minus 64. And then this is how much? 36. So 6 kilometer per hour. This is the velocity of so this again. This was a direct question, right? So quickly note this thing down, and then we'll question on rainman problem or rain problem, and then we'll talk about the uniform circular motion, and then we'll start the laws of motion. So yes, if it is clear, then quickly note this thing down, and then we'll do the yeah. Whenever you guys have noted, just it earlier joined back. Yeah, and you guys can tell me that why didn't, because it was not given the shortest right? So why didn't in the value, this would have been 8, this would have been 10. So this is impossible, right? This should be smaller. So that is why we have this pass. This was boat and this is it is. Right. In the earlier question we saw that this was the resultant, the both, but now we have a difference. Everyone, think noted?
Yes, sir,
I
done.
guess, yeah. So it will not take that time. So let's do this. What is happening in the background? So that is ambulance, right? What is that? Okay. So let us do this question. This is a tough question. So when a car is at rest, its drivers use raindrops falling on it vertically. When driving the car with speed v, so now we will use the idea of relative velocity. Right, he sees the ray that raindrops are coming at an angle 60 degree from the horizon. So we have this thing, right? And this is the velocity of the car, and then this is the rain falling, but he sees the horizontal, right? So this is what is, let's say, right? So this is what is. So with the horizontal, this is making 60-degree angle, right? From the horizontal on further increasing the speed v. So let's write in this way. This is rain. This is velocity of the car in the negative direction, and this would be angle, right? Now we have to find out this, right? So this is VRC, which is VR minus VC, right? And we know that what would be VR. So V, so we have this angle. So tan 60 would be how much? Tan 60. This is perpendicular. Velocity of the rain is perpendicular, and this is the velocity of the car. So tan 60 would be VR by velocity of car. So we can find out what is velocity of the river. This is root 3, and this is how much? Vc is v. So velocity of the river is root 3v. Right, this is case first. Now what is happening is that when the driver of the car on further increasing the speed of the car. So now he has increased the speed of the car to 1 plus beta v, right? And now this is the rain falling vertically. So if we calculate the relative velocity, this is the relative velocity with respect to car, right? So again, this velocity is 1 plus beta v. We are only talking about magnitude, and this is VR. So we know that tan of 45 degree. How much this thing would? So this would be perpendicular VR by this velocity. whatever the velocity of the car. So 1 plus beta v, right? So tan 45 is 1. This is the VR, and then 1 plus beta v. So 1 plus beta goes the other side, and then VR we have calculated v divided by this how much v. So beta is 3. So beta is root 3 minus, which is 0.7. So this is the value of beta. Right, it is clear. So there are two scenarios. And remember that we have to take, in the case of the rain, we always take the relative velocity, right? So we take this. So this was the question, and if it is clear, then please note it. The, so, oh, joint. There's the joint. Okay, Malia, yeah, so you are back. So we have just discussed this question. This is the question that we have discussed, in which in one case we had this angle, right, and the other case we had this angle. So we have just used the trigonometric ratio, and then we have found please note this thing down, and then we'll do the uniform circular motion. Yeah, whenever you guys have noted, please tell.
Noted, sir.
Noted. Good. So now let us do the next question, right? So let me. So now we have this uniform circular motion, right? And this is not a uniform circular motion, but this is the angular dependency of right. So how this is dependent upon the time, and we have to find out the average velocity, angular velocity from t to 0 to 2 seconds, and then we have to, let's say, find the instantaneous angular velocity at t equal to 3 seconds. So these are the questions, right? So we have this parametric form theta, and how we can calculate the average angular velocity, average omega, that is delta theta by delta t, right? Which means that theta final minus theta initial divided by t final minus t initial. So what is theta final at 2 seconds? This is 3 into square plus 2 into 2. We have to just put the value of time in here, right? And this is how much? 4, 3 are 12, 4 plus 1. So this is 17. And then theta initial is theta at 0 seconds. So t is 0. And then 1. So this is simply 1. So what is the change in the angular displacement? That is simply 17 minus 1 divided by t final 2 minus 0. So this is 16 by 2 So this is 8, right? And radian per second. So that is the average angular velocity. And the second part, instantaneous one, that would be d theta by dt, and at time equal to 3 seconds. So d theta by dt would be 60 plus 2 at t equal to 3. So 6 into 3 plus 2. So 18 plus 2, 20 rad per second. So this would be the answer, right? This is how we calculate the average and angular velocity. Average and instant. So quickly note this thing down and then we'll do the next question. Yeah, quickly note this thing down and whenever you guys have noted, please tell. Yes, noted guys.
Yeah.
Okay, so now let's do this question, right? It's part. Yeah, and we need to find out, right? First, we need to find out what is. So we need to find out what is the radius. Radius is not given. So let's say that radius of the circular track is r, right? So let's say the radius of the circular track, radius is, let's say r. Okay. So a body completes 5 revolutions in 10 seconds on a circular track. Calculate angular velocity, calculate linear velocity, centripetal acceleration. So these things we have to calculate, right? So let's say first we have to calculate the angular velocity. So angular velocity would be the angular distance, or let's say not angular velocity, but angular speed, because we are only focused on, right? Because then we have to calculate angular displacement, and that would be, so let's say we are only finding out angular speed, right? And then, yeah, linear speeds that we can. Okay, so what is the angular speed? That would be simply angular distance divided by time, right? So in 5 revolutions, how much is the angular distance covered? How much is the angular distance covered? Yes. How much is the angular distance covered? How much is the angular distance covered? So let's say we have this circular track, right? In one revolution, if it covers one revolution, then it covers 360-degree angle, which is 2 pi in one revolution, right? In one revolution, 2 pi, in two revolution, 4 pi, then 6 pi, then 8 pi, and then 10 pi. So in 5 revolution, it covers 10 pi angular distance, right? So angular distance is 10 pi divided by time is 10 seconds. So this is simply pi radian per second. That is the angular speed. So linear speed is simply v is omega r. So omega is pi, r is r. This would be pi r. Pi r meter per second, right? And then we have to find out the centripetal acceleration. So let's say centripetal acceleration we have to find out. So how much would be that? This is omega square r, or we can write v square by r. So v square is pi r into square and then divided by r. So pi square r square divided by r. So this is pi square r and meter per second square. So this is the centripetal acceleration. Okay, is it clear, guys? If it is clear, then quickly note this, right? And then we'll do the next questions. Yes, noted, guys. Yeah, whenever you guys have noted, please.
Yes.
Noted.
Yes.
Okay. So then let's do the next set of questions. Right. So this thing will find the time period of meeting of minute hand and second hand of the clock, right? So that you guys have to solve. Now we can do this question. This one is an important question, right? And only the result is the object is moving in this direction, and now it makes a theta angle, and now it is moving in this direction. These velocities are same, magnitudes are same, only the direction is changed. So then the change in velocity, this is simply 2p sine theta by 2, if I remember it correctly, right? So let me just derive this, because let's say if I have forgotten that. So let's say that, yeah, this is V1, this is V2. So V1 is simply, let's say, Vi hat. V2 would be, because it is, let's say, going in this direction and then this direction. So this will have theta, so this is p cos theta, and you guys don't have to write this, right? So p sin theta, so change in velocity, V2 minus V1. This is V sine theta G. So magnitude is how much? V cos theta minus V whole square plus V square sine square theta plus V square minus 2V square cos theta, and then this is V square sine square theta. So we have 2V square minus we have right. So V square that is, and then V square 2V square and then 2V square cos theta. So what we can write? This is V is common, root 2 is taken outside, and then this is 1 minus cos theta. So what is 1 minus cos theta? How we can write this 1 minus cos theta? So this is 2 sine square theta by 2. So this would be root 2 into root 2 sine theta by 2. So yes, this is 2e sine theta by 2. Okay, so you guys have to remember this thing, right? And forget about rates. You have to just remember that what is the change in velocity. So whenever you have these kind of questions, you have to just remember that what is the change in velocity. So magnitude of change in velocity is 2b sine theta by 2. 2b is given theta by 2. So sine of 60 by 2. That is 30. So 2 into 10 into sine 30, which is half. So this would be 10 meter per second. Right. This is the change in velocity of this thing. So this is the question. If it is clear, please note it down. So you have this circular motion in which this has covered, the object has covered 60-degree angle. So you have to find out what is the change in magnitude of change in velocity. Yeah, please note this thing down, and then we will talk about laws of motion, right? So this thing is done, and now we'll talk about the fourth chapter, which is laws of motion. Yes, quickly note this thing down. Note it, guys. Note it. Yes, note it, guys.
Yes, sir.
Okay, so then yeah, then this is not important, but guys can right. So you have to just break the components, right? This was what was in the given figure is the total acceleration of particle in the clockwise direction. Radius is this, the speed of the particle you have to find out, right? So what was this question? So let's say, yeah, this question, let's see, yeah, this question quickly. And so what they have given is that the radius is this, acceleration is this A, and this is 30-degree angle. This is moving in a circle. Let's say it is moving in here, right? So this is right. And now this acceleration is making this theta angle, so it will have two components. What would be this thing? Can you guys tell me what would be this component? This is the angle, so what would be this angle component? Can you guys tell me? Let me just remind you the resolution of vector. This is theta. Let's say this is some r. So what was this component? What was this component? This was horizontal. So how much was this? R cos theta. This was r sine theta. Right. Similarly, how much would be this thing? How much would be this thing? So this would be a cos 30. This would be a sine 30. Vertical part. Now, this is towards the center. So what acceleration is this? What kind of acceleration is this? Whatever acceleration which is towards the center. What acceleration is that?
Centripetal.
So centripetal acceleration. Good, absolutely correct. So AC is A cos 30. And what is the relation between AC and velocity? Remember, we have to find out the speed of the particle. So how this AC is related with speed? AC is V square by R. We have just learned. Right, this is A cos 30. So we know that V square would be AR cos of 30 degree. So how much is this thing? A is 15. R is 2.5. Cos 30 is root 3 by 2. So how much is this thing? Okay, 2.5 and then 15. So what would be this thing? We have to multiply this thing. Let's do this calculation. So 15 into 2.5. So that is 37.5 divided by 2. This is 18.75 into root 3 is 1.732. So this is 32.475. And now we have to take the root. Right, so now we have to take the root of this. So what is the root? 3 point, oh, we don't have the option. Okay. So we don't have 3.19. Okay, let's check the answer then. So represents the total acceleration of the particle. This is 30. So this component is A cos 30. A cos 30 is V square by R. So V square is RA. R is 2.5 and this is 15. So what did we miss? 15 into 0.5 equals 37.5. Is 1.73. 1.73 into 37.5. 37.5. 64.95 divided by 2. 32.475 square root 5.694. Oh, this root is, yeah, so V square is 32.475 and then V is 5.69, which is 5.7 per second. So this would be the answer. Is it clear? So we have to just write the centripetal acceleration, which just found out, right? So this would be centripetal acceleration towards the center, and then we just equate it with the relation of the velocity. So then we'll get the result. Quickly note this thing down, and then we'll start laws of motion. In laws of motion, you guys need to first note down the concepts. So I have already noted those. I have already written those. Guys have to just note it. Yeah, quickly note this thing down, guys. Just note it down. Yes, noted, guys.
Yeah.
So now let us start this laws of motion. So what are the topics that we have studied in laws of motion? So we have first studied what are the three laws of motion. We have talked about free body diagram, friction, pseudo force, dynamic of circular motion, and banking of fluid, and motion of vertical circular. So this much topic we have done, right? So whatever point which is needed to be noted down, I'll just talk about those. But rest of the things, I'll just give you guys a quick glance, right? So in laws of motion, we have talked about first law is law of inertia. Second is about the external force. This external force is ma whenever your mass is constant. So, but usually it is dp by dt, change in momentum divided by change in time. So that is the force, and then the third one is action is equals to reaction, right? So for every action, there is always a reaction which is in the opposite direction of the action. So these are the three laws, and then we have the impulse also, right? So impulse is simply change in momentum, right? And this is also equal to the force into time. So this impulse time is quite small. So this time would be acting for a very small time, right? So impulse is change in momentum, impulse is force into time. So we can use any relation which is needed, right? So let's do some question using these ideas. These things you guys already know, right? You guys know about impulse, you guys know about laws of motion. This is not needed to be noted down, right? When we'll talk about vertical circle, when we'll talk about banking of the roads, then we'll talk about these things. So just you have to remember that impulse, right? This is force into time or this is change in momentum, right? Which is mv minus, so we can write these things. But if we have a variable force, then impulse is integration, right? But that thing is not in the syllabus, right? So this thing is not needed. So we will only have this constant force for our case. Yeah, and what are the questions? Yeah, let's quickly do some questions, and then in the next class, maybe in Sunday, I will try to complete this. Right, one class we have, so I will try to complete. So first, let us do this question. So a ball of mass 0.5 kg is dropped from a height, strikes the ground, and rebounds to the same height. The magnitude of impulse imparted to the ball is here, right? So we have to find out the impulse, and this would be what? This would be change in momentum. So we have to find out what is mv minus u, or we can also calculate. the force, and then we can find out, or yeah, so but this would be easy to calculate, right? Change in momentum. So what is the change in momentum? First thing is that right. Before striking, what was the momentum, and after striking, what was the so let's find that out. Okay. So it is a drop from this height. U is zero for this part, right? U is zero. So what is the final velocity in here? Height is h, and we know that g is 10. G is 10. We have to take. So v is u plus at, which is u plus gt, or we have to use the other relation. So v square minus u square is gh. U is 0, so v is simply root 2gh. How much is this thing? So let's say this is the magnitude, right? So momentum impulse is a vector quantity. So this is the final moment. Initial momentum would be what? V initial, this would be mass into V, whatever with the velocity with which it strikes. So that is V, and then direction is minus j hat. Right. So this is m root 2gh and minus j hat. Right. So minus m root 2gh j hat. This is initial momentum. What is the final momentum? So let's say what is the momentum with which it is imparted. So it would be imparted with the same velocity, right? So then what would be the velocity? So velocity would be root 2gh, but that would have the opposite sign, right? So v final, this would be root 2gh, and if I write the vector, so this would be in j hat direction, right? So final momentum, this would be mass and root 2gh, and this is how much? J hat momentum. This is P final minus P initial, which is m root 2gh, and j hat minus of minus m root 2gh j hat. So this is 2m root 2gh j hat. So this is the magnitude, right? This is the magnitude, and this is the impulse. So impulse is 2m root 2gh. So what are these values? 2m is 0.15, and then root 2, 10, and h is how much? 10. So how much is this quantity? So 15 to the 0.3, and then what do we have? Root of 10 root 2. So this is 10, 0.3, and 1.4. So 14 threes are 42, right? So this would be 4.2. So this would be the answer. Right? Is it clear, guys? So we have to write, or we have to use the idea of vector quantity. So that is why we have extensively talked about these vectors, right? So if we write the vector parts, then this would become very easy. So calculation becomes very easy if we write the vector parts. Okay, just note it down, and I guess we have to do rest of the question in the next class, right? So we'll do that in the next class. Okay. Yeah, so please calculate, or please note this thing down, and whenever you guys have noted, just tell me. Yes, noted, guys.
Yes.
Okay, so then, yeah, we'll stop here and we'll continue from